Hello everyone. In this video we will learn how to change coordinates from Cartesian to polar and vice versa. Well, remember that for a point on the plane, now we have two different coordinates. One is Cartesian coordinate given by x and y. The other one is polar coordinate by r and theta. While x and y are the image of basically point on x and y axis, r and theta are the radial and angular coordinates. Well, for the same point, there are relation between these two set of coordinates, and you can turn one to another one. So this is the fact or the theorem, whatever you like to call, is that if x, y, and r theta are coordinates Cartesian, the first one is Cartesian, and a polar, the second one is polar coordinates of the same point, then there's a relation between these ones. For example, you see that x and y can be obtained just by knowing the definition of trigonometric function, because this guy is x and this is right triangle, so this will tell me that x is going to be r cosine theta and y is going to be r sine theta. So if you basically know what are r and theta, you can use these two equations to go from polar to Cartesian. And to go backward is a little bit trickier because, well, okay, you can say that r is the length from that point to the origin. So you can go x squared plus y squared. Well, the better version, because r can be negative one, but this gives me just positive. The better version of this is this: r squared equals to x squared plus y squared. On the other hand, a tan theta is going to be y over x. In other words, if you find tan inverse of y over x, you are getting theta. Not really, because tan inverse just covers between negative pi over 2 and pi over 2, but theta can be anything. So this is almost not all the steps going from Cartesian to polar. Okay, so so let me just write that as a remark here. When using tan theta equal to y over x, when we have x and y, sometimes we first find we can find more than one theta satisfying the coordinate, the equation. To fix only one, we have to check the quadrant of the point. So we will do some example, but just know that when we are using this, there will be more than one theta. To fix it, you have to see in which quadrant that theta is and then find the proper theta. Let's do example. Well, going from polar to Cartesian is easy because if you know the point in the polar, then right away you know what is r, you know what is theta. In this case, theta is 2 pi over 3. And then you can go ahead and find x as r cosine theta, 2 cosine of 2 pi over 3, and y as 2 sine of theta. Cosine of 2 pi over 3 is negative half. So the x coordinate is negative 1. Sine of 2 pi over 3 is root 3 over 2. So this is going to be root 3. So then the Cartesian coordinate or rectangular coordinate is negative 1 root 3. For the second one, these are just straightforward. 2 negative pi, that means that r is 2, theta is minus pi. Then from there, you can go ahead find x, which is r, 2 cosine of minus pi, which is theta. Y equals to 2 sine of minus pi. Cosine of negative pi is negative 1. Sine of negative pi is 0. So we have the point Cartesian coordinate is negative 2 and 0. And the last one, negative 2 pi over 4. So r is negative 2. Theta is pi over 4. Then from this, you can go ahead find x, negative 2 cosine of pi over 4, which is negative 2 times root 2 over 2, which gives me negative root 2. Y is negative 2 sine of pi over 4. So negative 2 root 2 over 2. This is negative root 2. So the point is negative root 2 in the Cartesian coordinates. When we're going backward, the work is a little bit difficult. Well, not difficult, but you need to be a little bit careful. For example, the 2 and negative 2 here, that means that x is 2, y is negative 2. Then right away we go ahead and find r. Well, you can always find the positive r if you're finding the coordinates. So this will mean that r is root of 4 plus 4 root 8, which is 2 root 2. And now I'm looking for theta whose tan is y over x, negative 1. So then in that case, you see that the angle whose tan is negative 1, at least on the interval from negative around 0, there are, well, theta can be negative pi over 4, or it can be 3 pi over 4, or it can be, 7 pi over 4. But this is basically this plus 2 pi. So there are two answers on the interval minus pi or pi, or you can say two angles between 0 and pi. I can make it like this, 7 pi over 4. So these are two angles in negative from 0 to 2 pi. But if this is the theta, this will go to the second quadrant, yes? this guy will go to the third quadrant. What is our coordinate in the Cartesian? This is x is positive, y is negative. So that is in the fourth, not third, sorry, in the fourth quadrant. Fourth quadrant. And you see that the second quadrant one goes away. So my polar coordinate is going to be 2 root 2 7 pi over 4. Let's start with this one. So 1 and 0. So that means that x is 1, y is 0. From there, we can go ahead and see that, okay, r squared is going to be 1 squared plus 0 squared, which is 1. So I pick just the positive root of that. So r is 1. Tan theta must be y over x, which is 0. Here, then theta can be either a 0 or pi. If it is pi, it's going to be on the negative x-axis. But this is on positive ones, and that's why this will go away and our theta will be 0. So this is 1 and 0. The same one. Yeah. And the third one here, 0 and negative 3. So x is 0, y is negative 3. And you go from there, you see that r squared is going to be 0 squared plus negative 3 squared. This is r is equal to root 9. We get the positive one. For theta is negative 3 over 0. Well, we are expecting this, well, it's not defined, yes? But when it comes to the angles, you see that on the y-axis, any point on the y-axis will give you the same situation. So it is either the angle is pi over 2 or 3 pi over 2. So from this, theta is either pi over 2 or 3 pi over 2. So if it is on the positive y-axis, which is not, that will be pi over 2. But now we are on the negative one, so this is 0, negative 3 here. So that means that this is not acceptable in this case, and our polar coordinate is 3 and 3 pi over 2. There's one more left. I will leave that one for you. But you see that when you're going from Cartesian to polar coordinate, to find theta, you have to work a little bit more.